In this class, let's try to find the deflection of a cantilever beam which is subjected to a point load at its free end. Okay. So now here you can see that I have already got a point load over here, W. The length of the beam is L. Okay. And I have taken a section X. So from the previous discussions, we know that in the deflection of a beam, we have a general deflection equation which is like this. MEI into d square y divided by dx square is equal to m. Okay, this is from our previous class. Now let us take this beam now, right? So in this beam, what's happening? Let's say if I apply a load over here, then what happens now if I apply a load over here? Now see, the beam gets deflected like this, is it not? The beam gets deflected like this. This means you have got some deflection over here. This deflection is, let me call as y, and there is some slope also over here. This I will call as theta. Okay, now I have this. So now I have to find out y and theta. That's what I have to do with this one. I have to find an equation for that. Now we also know that bending moment at xx is equal to what? I can write it as m of x is equal to W multiplied by the distance x. It is with a minus sign because the beam is bending downwards. Okay. If I equate the above two equations, then what I will have? I will have EI into d square y divided by dx square is equal to minus wx. Let me integrate it. If I integrate it, what I will get? E and I are constant, so I will keep them outside. E into I integral of d square y divided by dx square. I will have some constant. That constant, and on the right side also I have constant. I will put them together and write it. Okay. So I have to write dx here is equal to minus w integral of x dx. Now let me integrate it. When I integrate it, what do I get? EI into dy by dx is equal to minus w into x square by 2 plus there is a constant here on the left side, on the right side, put together I will write it as C1. Okay. Now what I need to do now? I need to put the boundary conditions. Let me put the when the value of dy by dx is equal to 0, see the slope will become 0 at this point, is it not? That is when you have got sorry, something came here. Okay, so when this will become 0, dy by dx will become is equal to 0 when x is equal to L, dy by dx will become is equal to 0. So now let us just try to put this condition. Then what will happen? 0 is equal to minus WL square by 2 plus C1. So therefore what will be the value of C1? Therefore C1 is equal to WL square by 2. Okay. Now what I will do now, I will use this one into this equation. I will call this one as equation number 1. So therefore I will have EI into dy by dx is equal to minus wx square by 2. Instead of C1, I will write it as what? WL square by 2. Okay. This is what? This is your equation for what? This is your equation for slope. Okay. This is the equation for slope of the beam at any condition, understand, at any distance x. Okay, this I have. So now again I will integrate. If I integrate again, what I will have ei into integral of dy by dx into dx is equal to minus w by 2 integral of x square dx plus wl square by 2 integral of dx. Is it not? Now when I integrate, what I get? I get ei into y is equal to minus w x square. Integral of x square is what? X cube by 3. So that 3 multiplied by 2 becomes 6. I will write it as w x cube by 6 plus wl square by 2 into x plus c2. Okay. Now I will apply the boundary conditions. When the value of y will become 0, when x is equal to L, you can see y is 0 here, is it not? There is no deflection there at the support. When x is equal to L, y is equal to 0. So therefore what happens? Therefore 0 equals minus w L cube by 6 plus w L square, and L means again L cube. L cube by 2 plus C2. Okay. Now what will happen now by taking LCM and doing all that stuff? I can write C2 is equal to how much? C2 can be written as minus WL cube by 3. Minus WL cube by 3. Take this one and put it in the equation there. So you have EI into Y is equal to minus WX cube by 6 plus WL cube by 2. Sorry, WL square by, sorry, WL square by 2 into X plus C2. C2 is what? C2 is minus sign, is it not? So I will write it as minus WL cube by 3. Okay, this is what? This is the value of equation for deflection of beam at any given distance x. You can easily find out. Right. Now, what is the deflection at B? If I call this my beam as A, and this one if I call as B, what is the deflection at B? And you can find out slope at B, is it not? So at B, what is the value of x? The value of x is 0, is it not? So I will write at B, if you put x is equal to 0, then what will happen? W L square by, where is the formula? The formula is here.